right? The addition rule is the or statement, all right? The addition rule is how we find the probability of an or statement. And that is the probability of the first plus the probability of the second minus any overlap that you have, minus the probability of the first and the second. Essentially what this is kind of doing, if you think about your sample space, as well as these, the elements that are lying in each of these events, it's the same as taking those two events and molding them together, but then you have to subtract out anytime there was an overlap, because essentially those pieces, those possible outcomes got counted twice when you molded or pushed the two original sets together. So that's where that minus part comes out. You have to subtract out anything that was repeated twice. Let's look at an example. First, a little bit of a review example from a previous one, and then we'll look at one where we use the actual or statement. Okay, this is kind of a multiplication and statement or statement combo example. Felicity attends a junior college. The probability that Felicity enrolls in the math class is 0.2. So I'm going to name this just because I like to have the variables. The probability that she enrolls in a math class is 0.2. The probability that she enrolls in a speech class, I'm going to call it P of S, is 0.65. The probability she enrolls in a math class given that she's enrolled in a speech class, math given speech, is 0.25. So that's the information given to me in the written out example. They want to know, what is the probability that she enrolls in a math and a speech class? So they want to know, what is the probability that she enrolls in math and speech? All right, well, it's going to be the conditional probability times the latter. So in the other direction, when you were doing the formula for conditional, it was the and statement divided by the given piece. Here, if you're looking for the formula for an and statement, it's the conditional. So in this case, P of M given S. And then instead of dividing out the bottom or the given, we multiply times P of S. Right, we already have both of these pieces of information, so we just plug in at this point. P of M given S is 0.25 times P of S is 0.65. We put those into our calculator, multiply them together, and we should get 0.1625. All right, now they want to know, what's the probability that Felicity enrolls in a math or a speech class? So remember, this is one or the other, or both. This could be her enrolling in both. So that's the probability she enrolls in a math plus the probability she enrolls in a speech. But remember, if we were looking at a physical sample space, which is a little harder with this concept, it's not like talking about rolling a dice 6 times. Like instead here, you're given the probabilities instead of figuring them out on your own. But if we were looking at a sample space, there's these outcomes where she enrolled in math, these outcomes where she enrolled in speech, sorry. And then if we push them together, there were some outcomes where she could have been in both, and they would have gotten counted twice when we pushed them together. So those have to be subtracted out. The probability she enrolls in math and speech. And we just plug in all of our values here. The probability she enrolls in math is 0.2, plus the probability she enrolls in speech is 0.65, minus the probability she enrolls in math and speech. Well, that's the number that we had just calculated, 0.1625, which is why this needed to be a combo problem. All right, once we put that into our calculator, we're going to get 0.6875.